opportunity. Deepak, wherever you are, thank you very much for this opportunity. And today I got this opportunity to listen to a lot of experienced people about what they feel about IT and government put together, which is quite rare because we seldom get to hear their views. So that has been a good learning, and I actually jotted down some of the points which I liked very much. That this one, yeah. So something that I captured was that government unable to deliver goods to people because of the system, and if we have IT-enabled systems, that would mean that we reach the citizens directly, and we're able to turn around it in a shorter time and a proper manner. So that is a good. Then conservation of energy was another point, and these are some of the really the boiling points, which today's presentation I would like to link them to this presentation. I belong to the storage division of HP, and from the storage perspective, I've been with this division for 10 years now in HP, and I have seen it grow and change and transform. When we started, the storage was very small. It was just about, say, 5% or 3% of the total IT infrastructure. But as things are becoming more and more IT enabled, we see that a lot of data is accumulating, and it is coming from all directions. The servers are moving, servers are going, the CPUs are moving, but the data is constant. Constant meaning the old one is also there and new one is also adding up. So this has raised the complexity of how to manage that data. And the departments were smaller at that point of time. The data was little, but now since it has become huge, scattered, distributed, it is really becoming a challenge. So I would like to put my views. I do not want to make this into a technical discussion, but I will skip few slides which I think are not relevant, and keep it and try to link where I think that makes sense to the enablement of IT in the government space. Right. So what we introduced lately is a new product, and a new product meaning that we acquired a technology called 3PAR. Now this 3PAR technology, the reason why we acquired it is that we're seeing that earlier the data was growing in silos. We saw that divisions were small. If you can link it to a government organization, we saw that there were regional offices or regional departments. The data was spread there, and slowly that data need to be accumulated to a central place. Now for a decision to make or happen, we have to link these regional centers, make a common repository, like what UID is today doing. We're trying to collect all the data of all the citizens and keep it in a place. So the storage has changed from being a distributed architecture to a centralized architecture. And how that will help us? That will help us by saving the overall, the overall space required, the overall management cost, the energy that is to be used vis-a-vis distributed to a centralized architecture. And so this change has happened, and people are working towards this change. So as I told you that we listen that it is too complicated to manage now, it is expensive, it is disconnected and isolated. And when I say it is not infrastructure, we are talking about the information, because ultimately data is information today. And it has become very inefficient and inflexible, and we would like to see it simple, scalable, smart, and self-optimized. So we like to bring in that efficiency into the storage element, which is now at least 75 or 60 to 75% of the data center requirement. So we introduced a technology called 3PAR, and some of the features that it has is like thin provisioning. I will not get into detail, but thin provisioning meaning that you use as per your requirement. You save the space required to store the data and only provision that much what is required, right? Then you can have multi-tenancy kind of architecture. Now since there are different divisions, for example, state data center, if there are different divisions that want to now have an application on a storage, what is their approach? Will they go for multiple storage in a state data center, or will they have a common storage, and that storage should be able to support different kind of workloads for different applications in the same data center? So this is how you bring in that efficiency, reduce the power, cooling, space, right? Then you look at the mesh architecture. Now today what has happened that I look at 5 years from now, since India is growing, so I look at it and say that from 5 years my data size will be this much. And so I provision something which is this huge. But today I only need this much. So whether I should look at architecture which is big enough for 5 years, or look at an architecture which is small today but can grow as the data requirements grow. So my investment upfront is low and I grow as per my requirements, because I don't see a trend of how the requirement will increase. So these are some of the features that this new architecture is going to bring in. Okay, so now when the architecture is going to be shared, then of course the security parameter will come, that one division will say that I don't want to share the storage because I don't trust the other division, and whether my information will be used by the other division or be seen by an administrator of the other division is a question mark. So the security parameters should be high here, and this is what is also a change that has come into the picture. And number two is, when a new application is going to be deployed, how fast can I deploy it? Is it I will need a lot of things and it will take me 1 month to deploy the application, or is it that within seconds or minutes I have that space for the new application which I want to deploy? So the deployment needs to be faster, and the storage that we are going to deploy needs to support it. So this is another important feature that has come in. So these are the models which I won't touch, but this is a family of products, and the family of the product means that all across it is the same architecture, same software, and same features, so that you can start small from a 200 model and scale to a 800 model as and when the requirements come up. And this is briefly the architecture. What we are saying here is that if you see, there are about 8 controllers, 8 boxes, the colored boxes here, and so I can start with only 2. That means I start small, but the same architecture will keep on growing as my data center requirements grow. So it will not get obsoleted as quickly, because the technology is going to stay till the full cycle, and you are going to upgrade or enhance the performance as and when a new application or new environment comes into the picture. So this technology is best suited for a cloud kind of environment, where today we are seeing that a lot of private clouds are now coming into the picture. Corporate organizations are looking at clouds for their internal applications, and government organizations are looking at common data centers instead of multiple data centers, and so it becomes a cloud internally for them, and when they're going to provide these services to the citizen, it becomes a external cloud. So these technologies are very well tuned for providing cloud services, and till date the technologies that have been deployed are more or less kind of modular architectures, where they are fixed configurations and need to be changed or replaced every few years as the technology changes, because they are unable to meet the growth requirements, and hence they need to be upgraded or replaced. But here there is something where, as more and more users are coming onto the same platform, the scalability and the upgradability is available in the same platform. So I will not dwell much upon these slides, but what here we are trying to show is that it will, since it is based on the number of disks that you are going to use, the performance is dependent on the number of disks that are going to be used. This storage box is such design that it will use the maximum number of disks available, and hence it will offer a very, very high performance compared to a ordinary or a modular kind of architecture. So lower resources but higher performance. That is a key message here. Another important feature here that it brings, that we can now, today we don't know where the data is being stored, whether it is stored in the external part of the disk drive or internal part of the disk drive. This is a very good technological change that had happened. So we store a data onto a disk drive, but we don't exactly know where it is stored. Now, technology speaking, that if you store the data on the exterior part of the disk drive, it is much faster to retrieve or to write because it is on the outer periphery. But if you store it inside the inner sectors of the disk, it is slower to retrieve as well as to write. Now here the technology, what we are saying is, all the application data which is more frequently used, it needs to be accessed more frequently. I can tune it to be present on the outer sectors of the disk, and the data which is, say, for backup or it is not important, I can tune to put it inside the sectors of the disk, and so I am able to drive a much higher performance and use as per requirement. The technology further has changed, and it is now going to be a multi-controller architecture. Till now it is modular architecture, meaning there is only two controllers, two main CPUs which are handling the data. But now it is going to be a modular multi-controller architecture. And so as you see, two controllers and then 4 controllers and then 8 controllers. So I can grow as per my requirement. I do not need to remove those 2 controllers and buy bigger ones because my data has increased, but I can go simply and add 2 more into the same data center. And so my performance capability of that storage increases, and I continue to use the same cloud which I am using since quite some time. Another important thing when we see storage, why I said in the beginning, was that data has increased. Data is there, the old data is also there, and the new data is also coming up. And so the data size has increased considerably. Objective of the storage is to, how can you make a storage thin? It has increasing data. How can you make that storage thin? So there are various technologies that have now come in that can help you do that. There are a lot of space that are blocked by an application which is not used. So can I free that space and use it for another application? Right? And if I'm moving data from one storage to the other storage, can the new storage detect the space which is blocked and it is not being used, and can it free it up to use it for the other application? So these are some more technologies that are coming up, and as a result of this, we are seeing that people who are deploying these kind of technologies have considerably reduced the requirement. They have reduced it by, say, half or 1/3 of the total requirement that they need. These are basically thin provisioning technologies, and I can give you an example of Global Bank where 271 terabytes was there, and when they moved it to this new technology, they reduced the capacity by 50% because there was a lot of space which was just blocked and not being used. So these are some areas which need to be looked at while designing new RFPs, new requirements, so that it is well best suited and efficient. Another important thing, that sometimes the data is required very fast, sometimes the data is not required. There is a lot of time that I can take to provide that data. But so if I provide infrastructure where there is a mixed kind of drive, there is a solid state drive like your flash drive, there is a fiber drive, and there is a SATA drive which is the slowest. Can I mix them all up? And by mixing them up, I can reduce the overall cost, and also I can keep the data which is much more frequently required on the flash or the SSD drives, and which is not required on the SATA drives. Then I can get the efficiency at a much lower cost because I have now distributed it across cheaper forms of disk. So this mixing and cutting across these volumes is another new feature which has come into storage technology. This depicts that how it happens, and there are 3 tiers, and the data can move across these 3 tiers as per the requirement. The storage sees that this data is required more frequently, it will move it to the fastest. It will see that 1 week nobody has accessed the data, it will move to the slowest. So that way the performance efficiency is being maintained. So that's not all, that is just one of the products that we acquired, but this is the entire portfolio of HP Storage Works, where we provide the disk-based systems, the backup systems, the piece to manage all that, the network systems to connect all of it. And so there are a lot of products, more than 100 products from the storage itself, depending on how the architecture is, how the solution will be, what needs to be achieved. And these are divided between store, you store data, you protect the data, you optimize the data or the storage device, and then you manage it. So these are divided between 4 layers, and that is how you overall manage the data while it comes in and to the last stage where it may go out. And it is definitely brought from a leader. It is brought from a Fortune 14 US company, and one of the largest IT companies. And so the point here is that the entire portfolio is available, and we'll be happy to sit across with the different departments, study and give our consulting at how we should approach it and how to make more enablement in the government space. Thank you very much.